Hello, this is chapter 28, magnetic fields. Actually, the magnetic field exists in nature. For example, the core of the Earth is inducing some magnetic field around it. When the charged particles come from the sun, they would interact with that magnetic field, making these colors. And the charged particle coming from the sun, like electrons and other ions, could interact with the gaseous particles in the Earth's atmosphere, and they form these colors. Magnets exist in nature, and there's a magnetic field around them. So it's not something only made by human, but we can find it in nature. A magnet has two poles, north with south, and the magnetic field lines are going from north to south, and the vectors of the magnetic field are tangent to these lines. Now, if you think about dividing this magnet to separate north from south, you will end up with two magnets smaller than the first one, and each one would become also a dipole. That means each one would become north and south. Now, human beings maybe they cannot see or touch or hear or smell the magnetic field, but birds, bees, and bacteria can use the magnetic field to navigate, to go from one region to another because they have some magnetite and that would interact with that magnetic field so they would know the direction. So, for example, in this figure, you have in black the dark specks are the magnetic in a bacteria. Now, if you have a charge that is moving in a region where you have an external magnetic field, the moving charge would interact with that field in a way to create a force Fb, where Fb by definition is equals to Q times V vector cross multiplication B. So when you multiply two vectors in this way with the vectorial product, the magnitude of the force would be QVB sine the angle between these two vectors. Now for the direction, you have to focus to use the right hand rule with the three fingers. Whenever you have a formula with a cross product in it, you have to use the three fingers, where the thumb would be on the first vector, that the index would be on the second vector. يعني مثلا هون I have V cross B, so V هي على thumb will be هي على index, and finally the resultant, which is V cross B, would be on the other fingers. هلا if Q is positive, F would be on the direction of the resultant fingers. If Q is negative, F would be opposing the result of the cross product of the right hand rule. The palm of your hand is making a plane, and the resultant of the cross product is perpendicular to the palm of your hand. So the force F is perpendicular to the palm of your hand. It can be with your fingers or opposite to your fingers, all depends on Q. Now, if you have two magnets and you approach north to the south, they would attract each other. But if you approach north to north, you will see, you will feel that they are repelling each other. So opposite magnetic poles attract and like magnetic poles repel. We already talked about the electric field. They are created by static charges. But now the magnetic fields are created by moving charges. Now, this is the real reason for the presence of the magnetic field. هلا, if we have at the same time a electric field and a magnetic field and they are perpendicular to each other, they would accelerate the speed of an electron coming in this direction as shown in the figure. If you can see, we are creating some electrons from a filament, and then they are accelerated using a battery V, and they would enter the screen C from a small slit, and they will be accelerated using the cross fields because the forces are are perpendicular to the direction of V. So sum of forces QE plus QVB, because QE is the electric force and QVB is the magnetic force in vectors. So here, for example, you have the electric field directed downward and the magnetic field is directed into the page as X in green. If you want to find the direction of the electric force, you just multiply Q times E, and since Q is negative, so the force would be upward. And if you want to find the magnetic force direction, you put your three fingers. So the thumb is on V, يعني على orange vector, and B you are pointing into the page. So the force would be upward, but since the Q is negative, the force magnetic is downward. From chapter 22, when we only have one force اللي هي electric force, we can find the acceleration, and finally we can find the y اللي هي deviation on the vertical direction in terms of Q, the electric field, and the length L, etc. Now, if you focus on the cross fields region, you will discover that the two forces are opposing each other اللي هن ال QE اللي هي electric force and QVB اللي هي magnetic force. In magnitudes, if they are equal to each other, you will end up with a formula in the lower center of the slide, V equals E over B. In rotational motion, we have sum of forces equals ma that can be applied. But remember that we have two types of accelerations, A centripetal and A tangential, and you can see that the centripetal acceleration is directed on the radius of the circle, and the tangential is tangent to that circle, and they are perpendicular with respect to each other. Now, A centripetal has a formula. It is defined by V squared over R, where V is the instantaneous speed and R is the radius of the circle, or the radius of the curvature of the circle. So assume you have an ant moving or any particle moving from A to B, the distance is S. It is proportional to the radius or to the angle theta. At the same time, it is proportional to the angle and to the radius, okay? Where the units are meters for S and R, and the angle theta is in radians. So in case you want to increase your portion, your pizza portion, you have to increase whether the radius of the pizza or the angle of your part. Now we have three formulas, S, Vt, and At, where S is the dimension of the arc, okay, it's measured in meter. R is the radius, theta is the angle, and they are related as follow in the formula. And you'll understand it better with the formula of the pizza. I call it pizza formula. Now let's understand better acentripetal in rotational motion. Even if a particle is moving on a circle with a constant speed, يعني the change of speed is zero, يعني v prime is zero, okay, so AT would be zero لأنه AT هي derivative of VT. But AC is not the derivative of anything. It is V squared divided by R. So it only depends on V. So هذا الباص تخيلوا عندي باص وبده يلف كوع. So let's put for him a safety acceleration. مثلا بقول له if you surpass 8 meters per second squared, the bus would fall عن يد الكيرفتشر عن يد ال acentripetal. So بقول له 8 I will replace it محل ال AC and I have to find the V limit limited speed for the bus if the radius of curvature بكون بعرف أنا إنه الطريق عند curvature of 100 meters. I replace 8 meters per second squared in place of AC and I replace R with 100 meters. So I can find V, it is around 28 meters per second, which is 100 kilometers per hour. So I put a sign for the buses and cars that you cannot surpass this velocity. If you do, the bus would fall. Now we have to study the magnetic force on a moving charge. So initially the charge is moving with a velocity v1. Focus on the bottom point of the circle. Now, if you use the three fingers of the right hand rule, V1 is directed with the thumb, B is pointing to yourself because B is a point in this problem. Okay, the force F1 would be downward, but since it is an electron, not a proton, you take the opposite لأنه the Q is negative. You have to multiply the cross product يعني right hand rule by a negative. That's why F1 is up. Okay, بس تشوفوا الفورس perpendicular to V, it means إنه I have a circular motion. Remember, in this problem, we don't have electric field at all. It's not a cross fields region. It's just the magnetic field, no electric field. So in this case, the electron would follow a circular path where V and F are always perpendicular to each other. V is on the tangential direction and F is on the centripetal direction. So you know the center of the circle if you follow the direction of F1. Now, after a certain time, the electron will become on point 2, يعني V2 and F2. And again, if you repeat the right-hand rule of the three fingers, you put the thumb on V2, F2 هي على الإندكس, and the final answer is, sorry, if you put the thumb on V2 and the magnetic field on the index, okay, you will end up with a vector going outward from the circle. But remember, since it's an electron, it would be inward. So F2 is directed on the radial direction. Now, if you go to the figure B, again, but this time, the only difference is that we are using a proton, not an electron. So when a V1 arrives, when the proton arrives with a velocity V1, okay, and you use the right hand rule, the thumb with V1, you point to yourself with B, and the final answer F is downward. That's why the center of the circle is downward. In this case, you don't have to reflect your hand. خلاص لأنه the Q is positive, you keep the direction you found on your three fingers. So the circle is going down and you will see the charge starting to rotate in this direction as shown in the figure B. Now, if you want to find the radius of this circle, it is equals to mv over qb. How did we find it? Actually, in a rotational motion, when we have sum of forces equal ma, this a is the centripetal acceleration, and the formula of the centripetal acceleration is b squared over r. Here, the only force that you have is qvb. If you put qvb equals mv squared over r, you will end up with r equals mv over qb. You know that T equals 2 pi over omega, and omega is V over R using the pizza formula. So you can replace T by 2 pi over V times R is mv over QB. So you can find the period T as long as we know the magnetic field and the charge Q and its velocity and its mass. Now, the frequency is always related to T and omega. So if you know one of these, you know the whole package. لأنه T والF والأوميجا are all related. الF هي 1 over T والأوميجا هي 2 pi F. So if you find one of these three constants, you can find the two others. Now, one of the main applications for the magnetic force is in the Large Hadron Collider, where we accelerate some charged particles, to be precise, and they would circulate in this tunnel under Geneva, and you will find that they do some very important experiments. For example, in 2012, they discovered the Higgs boson. It's not just one lab, you have many labs on the circumference of the circle, and you can do some experiments for material science and the discovery of particles and subatomic particles, etc. هلا cyclotrons are also charged particles accelerators, but they are smaller than synchrotrons. Synchrotron هو مثل هيدا ال LHC اللي شفناه قبل شوي بس cyclotron is smaller. It is like 1 meter in diameter, that's all, and it can be used for medical purposes. The mass spectrometer is also another application for the magnetic force. It is used to identify the particles and to give a spectrum for the material that we have. So to characterize it, it works with, first of all, we have a region where we have a cross fields to accelerate the particle in a direction. Then it enters a region where we only have a field B2, so no electric field in the second region, and you will see some circular path, and it all depends on the radius r where the charge would hit on the detector. According to r you can find the mass of that charge and its charge. So we have two characteristics to identify, the q and m, and according to q and m you can identify your chemical component. هلا if you can see the formula in blue هي Q over M يعني ratio Q over M. ما فيني أقول إنه والله if I change the particle Q and M both can change. يعني أنا usually this formula is related to the ratio Q over M. ال E will be 1 will be 2 are constant. So R depends on the ratio Q over M. مش Q لحالها مش M لحالها. هلا it would be impossible to tell if Q and M are variable. You have to find the ratio. بس هون in this problem they are saying إنه they have the same mass. هلا you can say if R is small Q is big لأنه inversely proportional Q and R. بس لو ما قالوا لي كلمة same mass I couldn't tell. This is the most interesting part because you know that QV is the charge that is moving with the velocity V. It can be replaced by a current لأنه حتى الcurrent is a charge, a flow of charge. So of charges actually. So أنا كل ما أشوف QV I can كبها بالزبالة بحط محلها IL لأنه الآي هي أرستقراطية ما بتحمل فاكتور بيجي اللينث of the wire وبيحمل لها الفاكتور عنا. So بس تشوفوا QV you can replace it by IL. As you if you look at this formula FB هي ذاتها ال QVB بس هالمرة حطيناها ILB. وقصة cross product يعني you put the thumb على current I direction of I ال B على index and the force F would be the resultant. هون الحلو إنه ما في negative positive Q. ال I هي عم نعتبرها دايماً ال flow of positive charges. So هون ما في خوف إنه ال right hand rule تقلب. Okay, you put the I على thumb, ال B on the index, and finally ال F would be the result of the right hand rule with the three fingers. هلا if you work on a small wire رح نسميه DL شقفة صغيرة من الواير you can find the DF اللي هي الفورس صغيرة created by this DL when you have the interaction between I and B. Okay, now let's see what happens to a loop that is rectangular and having dimensions A and B. So already we know that we have a current. Once it enters a region where you have a magnetic field in blue, you can see the vector B is going up. So هلا رح يصير في interaction بين ال B وال I. Okay. Since B is perpendicular to I اللي هي بالupper في عنا 4 sides بالrectangle. Okay, لكن عندي 4I. So I would have 4 forces. أول وحدة رح نبلش بالhorizontal one on the upper side of the loop. So I is going to the left and B is going up. You put the right hand rule. The force F is into the page. If you think about the lower one, I is going to the right, so put it on the thumb. B is going up, so F is pointing to yourself. That's why we put it as a point when you use the right hand rule. You will find it as a point. It is out of the page. هلا if you look that if you notice إنه ال I is parallel to B على ال vertical wires of the loop أو vertical rods of the loop, you will see that the interaction is zero لأنه بس يكون ال B parallel to I. بتتذكروا خبرتكم خبرية الحرامة اللي إذا ماشيين نحن بالليل parallel على الحرامة منا شايفينه so ما راح نفوت ببعض. There's no interaction between B and I. The force would be zero لأنه sine angle إذا كان 0 or 180 is 0. That's why I didn't put any force on the vertical parts of the rectangular loop. The force only exists when the current I is intersecting B. It means there is an interaction between I and B. هلا, finally, when you have an object with two opposite forces applied on different points, صحيح sum of forces is zero, بس يعني ما راح يكون في عندي translational motion بس حيكون عندي rotation. وحكينا عن هذا الموضوع وقت بدي افتح باب. أنا I need to apply a force okay at a certain distance from the axis of rotation. That's why المسكة بتكون بعيدة عن ال axis of rotation تبع الباب. إذا حطينا المسكة على ال axis of rotation مستحيل يبرم الباب. كمان ديركسيون السيارة انتو you apply opposite forces on different points so حتى إذا وحدة up وحدة down أو وحدة left وحدة right رح يبرم الديركسيون. so انتبهوا صحيح sum of forces is zero بس المومنت is not zero أو التورك. شو هو التورك؟ هي force times the distance. يعني in this case الفورس F اللي هي فوق times the perpendicular distance اللي هي نص البي. Again if you apply it below التورك تبع الF اللي هي نقطة كمان هي الفورس F times نص ال B. So B over 2. That's why I put B over 2 times the magnitude of the force اللي هي IAB. Current I times dimension A times the magnetic field B. هلا من وين اجت ال IAB؟ أكيد هيدي من المagnetic force اللي هي ILB بس هون ال L length is A. So again B over 2 plus B over 2 راح يطلع لي B. That's why بتصير I AB اللي هن ال area of the rectangle times the magnetic field magnitude B. So هيدي ال IAB اللي أخير final answer of the torque هي ال current I times ال area times ال B magnetic field. Now congratulations because you are just created a motor because once you plug it in a current when you have electricity the loop starts to rotate if it is positioned in an area where you have a magnetic field. So you can see on the right figure عنا north و south هن in blue. شو هيدا؟ It's a giant magnet okay that is static and the magnetic field is always directed in a certain direction from north to south, from north to south. So the magnetic fields are in green, you can see it, it's going from M to S. And we have a loop, ماشي هي حديدة in rectangular shape. Once you plug it in the electricity, you will see that the loop starts to rotate. في torque عم تبرم المروحة. And this can be applied in electricity for بتعرفوا انتم في كتير اشياء بالبيت بتبرم and this is a motor. هلا when it rotates there will be some angle between ال area A vector and the magnetic field B. So remember that the torque is NIB sine theta. Okay, in this case we are converting the electricity into mechanics. يعني الروتيشن والtranslation usually هن شي mechanics يعني في شي عم بيتحرك. So in this case نحن we have electricity and we created some mechanical rotation. هون ما في translation, only rotation about an axis بتكون نحن مثبتين عليها اللوب. The magnetic moment vector بالأورنج تحت بالصورة. Okay, you have to use the right hand rule with the curved fingers. You put the mu on the thumb and you can guess a direction of I أو vice versa. يعني you have the direction of I on the curved fingers and you can guess the direction of mu. And the torque of mu of the magnetic field is given by torque equals mu cross B. The energy is minus mu scalar product with B.